All right, we are good to go. So what we're going to be doing today is we're going to continue on with what we've been doing for the last few weeks, which is hypothesis testing. And once again, we are now in the realm of this course where we're dealing with real-life situations, real hypothesis tests that are done in the real world, where all of those limiting assumptions that we needed in order to learn hypothesis testing have now been lifted. So we're actually getting into the hypothesis tests that psychologists actually do. So these are the hypothesis tests that I use. Dr. Ritchie would use these, Dr. Vegeta would use these, Dr. Rodriguez would use these tests. These are actual ones that are used in professional psychological work. So we've learned how to do the t-test for single sample designs, such as Harlow's monkey study. We learned how to do the t-test for dependent means experiments, where you measure a group or a sample before the treatment, and then you measure the sample after the treatment. Or you have two treatments, you measure the sample on treatment 1, and then you measure them on treatment 2. So today we're going to take a look at the third situation where t-tests are used, and this is where you have two samples, and one of them you give the treatment, and then the other one you have as a control condition. So that's another very typical type of psychological study. So we're going to take a look at that, the t-test for independent means. Before we begin this, just as a note that the social media development program that we've been working on, and also the innovations and suggestions surveys have been on hiatus for just a little bit. We will be reinstating those. We'll be getting back to those. As just other things needed to take priority, but that will be back in live, and now we'll let you guys know when we return to that. But in the meantime, we're going to take a look at a very famous psychology experiment. This time we're going to take a look at it for real, and this is the one where Loftus and Palmer discovered that the way that you ask a question can actually change people's memories for an event. So if there was a car accident, and we have an eyewitness here, we have this guy right there, when the police are questioning him to determine how fast were these cars going, the words that they use to ask the question can actually change his memory of the event. So that was a huge psychological breakthrough, because we always thought that memories were filed away, they were stored away, and if you needed to access them, you would just access the file and bring it up. This was a key experiment that showed that the way that you access them will actually rewrite your memory and change what you remember. So we're going to take a look at that study, and we're going to take a look at the tools, the statistical tests that Loftus and Palmer used in order to reach their conclusions. All right, so today we're going to take a look at that independent means t-test. Before we get there, just a real quick word on one-tailed versus two-tailed hypothesis tests. And this is, once again, moving away from cutoff t-scores and sample t-scores towards cutoff probabilities and sample probabilities. So we need a little bit of info on how to do one-tailed and two-tailed hypothesis tests using SPSS. And then we're going to take a look at the underlying ideas for the t-test with independent means. And then we'll run an SPSS example of it, and then the rest of the class we'll have for in-class practice. Okay, so if you recall, we are moving away from using cutoff scores and sample t-scores in order to do step 5 of our hypothesis test, where we decide whether to reject or accept the null hypothesis. And the reason we're doing that is because we want to be freed from having to use that t-test table. We don't want to have to use SPSS and our textbook. We want to be able to do everything sort of one-stop shopping just with SPSS. And SPSS does give us enough information to do that. And the information that it gives us is not a cutoff score, but a cutoff probability, which is your alpha level. And it doesn't give us a sample t-statistic. Well, it does give us a sample t-statistic, but what we're going to use is the sample probability, and that's the p-value. So our step 5 becomes when the p-value is less than your alpha value. i.e., when your sample probability is less than your cutoff probability, you accept the research hypothesis and you reject the null hypothesis. On the other hand, if your p-value is greater than your alpha level, that means that your sample probability is greater than your cutoff probability. Then we accept the null hypothesis and reject the research hypothesis. So that's the rule. However, we have to be a little bit careful when we're dealing with one-tailed and two-tailed hypothesis tests. So the reason for this is because if we look at the output, for example, for the dependent means t-test, this significance is your sample's probability of occurring. So that number there is literally the probability that you would get results this extreme if there was no effect. So this is in essence telling us that you have an 8 in 1,000 chance of getting results this extreme if there's no effect. What that means is that there's probably an effect, right? Your treatment is probably doing something, and that's why we would reach that conclusion. But it's very important to know what is that probability actually of. So what SPSS does is it figures out your sample's t-statistic. So that t-statistic right there, that 3.5 or minus 3.5, SPSS figures out that's where your sample is on the comparison distribution. So then what it does is it says, all right, if your sample is at minus 3.5 or at plus 3.5, if your sample is at either one of these tails, then the probability of getting a sample this extreme is the distribution or the proportion of the distribution that is in the tails. So the probability of getting a sample this weird or weirder is basically the distribution in the tails, and that distribution is that 0.08 of the distribution. That distribution in this case is 0.8%. All right, and that's why we reject the null hypothesis, because if the only way to get a sample this extreme, if the null hypothesis is true, we only have an 8 in 1,000 chance of that occurring. So we have a 992 out of 1,000 chance that it's the effect. Anyways, this is the link between those two. That's why the cutoff score and the probabilities work so well together, because they're directly linked. Now, notice that this significance here is two-tailed, right? So it's this and this tail. It's the proportion of this tail and this tail. And if we're doing a two-tailed test, if the question says, do a two-tailed test with an alpha of 0.05, then when we make our conclusion, we take our probability, our sample's probability, the two-tailed probability, and we compare that to our alpha level, and we make our decision, and in this case, we would reject the null hypothesis. That's for two tails. However, sometimes we want to do a one-tailed test. And again, we want to be able to do this whole thing in SPSS without having to resort to going to the table. And in that case, what we need to do is we need to basically interpret SPSS's output for a one-tailed test. So that's actually not that difficult to do, but you have to be aware of it. So the first thing to be aware is that SPSS will always give you two-tailed. There is no option to say, SPSS, I'm doing a one-tailed test, give me the probability of my sample one-tailed. So SPSS is always going to give you two-tailed. However, if we're only interested in the one tail, we just have to realize that SPSS is giving us the two-tailed probability, which means that the proportion in one tail is half of the proportion in the two tails, right? So that makes sense. The proportion in two tails is 0.008, so the proportion in one of the tails is 0.004. So that's all we need to do. We just need to realize that it's giving us the two-tailed probability, so we just cut that in two, so that we know what probability is in each tail. And then what we do is we only use one of the tails. So if we were looking for, was there an increase in the scores, for example, if this was a t-test that says, was there an increase in the scores, you take your negative tail and you say, thank you very much, thanks for coming out, thanks for playing, but we don't need you because we're doing a two-tail test. And then your p-value, your significance value, becomes the tail that's left over, in this case, 0.004. So that's the logic behind it. In essence, what the move is that if you're doing a one-tail test, you have to take the two-tailed p-value that SPSS gives you, and you got to throw away one of the tails, which means you basically take that p-value and you divide by 2. Divided by 2, toss one of those away. In this case, we get a p-value of 0.004. That's the probability of getting a sample this extreme, one-tailed, one-sided. And then we make our conclusion, this is less than this, so we reject the null hypothesis. So when you're doing a one-tailed test using SPSS, if you still resort to using the cutoff scores, you'll come to this exact same conclusion. But if you want to be able to do the whole thing in SPSS, take that p-value, which is always going to be two-tailed, cut it in 2 for the one-tailed test, and then you'll have the probability of one tail. So again, remember, it always gives you the two-tailed. So if you're doing a two-tailed test, awesome, you're done. Just read the score right off of there. If you're doing a one-tailed test, take those two tails, divide it by 2 to get the probability for the one tail. And then the last thing that I'll mention on this before we take a look at the dependent means is that this is for the p-value. The p-value is what you're allowed to cut in 2. Do not touch your alpha level. Alpha level, for however you want to remember it, is not up for debate. It's not for you to mess with. Alpha's alpha. Alpha stays alpha. It's so important it got the first letter in the alphabet, right? It's alpha. So don't mess with alpha. I don't want to see anybody cutting alpha in 2. I don't want to see you multiplying alpha by 2. I don't want to see you doing anything with alpha. Alpha is alpha. You don't get to touch an alpha until you get some more letters behind your name. But the p-value is a two-tailed p-value in SPSS. If you need a one-tailed, chop it in half, and then go about your hypothesis testing business. All right, any questions on the two-tailed versus one-tailed and how to get there in SPSS? Yep.
Does the t-critical change in that case, from the 1 to 2?
Yes, the t-critical would.
Okay.
So the sample t will not. So your sample t is where your sample is, two-tailed or one-tailed, but your critical t-value, it does. If you have to put all 5% into one side, it'll push that critical value back. If you split it, it'll push that critical value more extreme. So when you're doing your homework, and I know your homework asks for critical values, that's when you have to go to the table. That's when you have to say, am I on the one-sided or two-sided part of the table? And then what are my degrees of freedom? You can get that right there. And then you find your cutoff score. So nothing has changed in terms of how we do the one-tailed or two-tailed test using the critical cutoff scores. But if you do want, and we do want, to be able to do everything with just SPSS, we have to make sure that we're using the correct probability for our sample, realizing that the probability that SPSS calculates is a two-tailed probability. So if we want a one-tailed probability, we just chop that in 2, throw away the tail we don't want, and we end up with the correct probability. All right, any other questions on that? All right, so let's do this demo problem now, covering a t-test with independent means. So we'll set up a situation. So in this case, I'll read it off the screen here because I can't see the print. In 1974, Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness memory. In the study, college students watched a film of an automobile accident and then were asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. So this is the first time we have 2 separate samples. that are being treated differently. Right? This is the first time we have one group where this happens, and we have a second group where this other thing happens. So the smashed into group reported significantly higher estimates of speed than the hit group. Suppose a researcher repeats this study with a sample of today's college students and obtains the following results. So we have 15 subjects in the smashed into group, mean miles per hour of 40.8. 10 subjects in the hit group, mean miles per hour of 34. Do the results indicate a significantly higher mean for the smashed into group? Use a two-tailed test with an alpha of 0.05. So once again, for SPSS, before we get there, what we're doing right now, the setup that we're doing right now is different than our t-test for dependent means. In the t-test for dependent means, we took a sample from from an unknown population, and we measured it, and then we did the treatment and we measured the sample afterwards. And that works for some studies, some questions. It would not work for this one, because you can imagine what would happen if you were watching a video in an experiment and the experimenter came up to you and said, all right, in that video you just saw, the video you just watched, how fast were the cars going when they hit each other? Then you look at the experimenter and you say, 40 miles an hour. And the experimenter says, okay, great. Now let me ask you another question. How fast were those cars going when they smashed into each other? You would look at the experimenter like they have a memory impairment, like they just forgot what you told them. You would tell them the same thing again. You would say 40 miles an hour. There's no way to do this where you ask the same group of subjects the question twice. So what we need to do is we need a new design where we say, all right, we're going to take 2 samples from this unknown population, and we're going to ask one of them a question that's different, and that's going to be the one that's treated. So this sample here gets asked, how fast were the cars going when they hit each other? This sample here gets the treatment, and they're asked, how fast were the cars going when they smashed into each other? And we want to know, because of that smashed into question, does this sample change enough so that they now belong to a new population? They belong to the smashed into population. Or does it not make a difference how you ask the question, in which case they still belong to the population that was asked, how fast were the cars going when they hit each other? The bottom line is that this is the first time where we have 2 samples, 2 separate groups of subjects, one that is treated one way, how fast were they going when they hit each other, a second one that is treated a different way, how fast were they going when they smashed into each other. They both came from the same population initially. We want to know if the treatment, the different ways of asking those questions, has now separated them enough so that one belongs to one population and the other one belongs to another. All right, so that's the setup. So here are the raw scores that we have. So once again, if you're going to do SPSS, you need the raw scores. You need to know the score for every single subject. So here we have all 15 subjects in the smashed into group and their estimates of speed. And you can see that they were being very exact, 43.13 miles an hour, 48.49 miles an hour. And then over here we have the 10 subjects that were asked how fast were the cars going when they hit each other, and we have their estimates of miles per hour. So, new situation, we need to do a new t-test. However, very nicely, same 5 steps. So it's the same 5 steps that we've been doing this entire time. Those have not changed. Just some of the SPSS calculations and setup will. So let's take a look at those 5 steps right now. First off, step number 1, restate the question as a research hypothesis and a null hypothesis about the population. We want to know, is there a difference in the speed estimations between the smashed into group and the hit group? So that's a psychological question we want to ask. We've got to rephrase it as a statistics question. Specifically, we need a null and a research hypothesis. So the research hypothesis in this case is that there is a difference in the speed estimates, and we write that as saying that the mean speed of the smashed into population does not equal the mean speed of the hit population. That means that the smashed into population has changed and now belongs to this treated population. The smashed into population no longer belongs to the hit population. It has now changed enough so that it belongs to its smashed into population. That's the research hypothesis. Null hypothesis has to be the complete opposite. Null hypothesis is that there is no difference in the speed estimates, that the mean for the smashed into population equals the mean for the hit population. They're the same population. They're the population that the hit group, the hit sample, and the smashed into sample still belong to. So that's step one, restating the questions as research and null hypothesis. Step two, determine the characteristics of the comparison distribution. SPSS will do this, and thank goodness, because this is a multi-step computational problem. So thank goodness we have SPSS right now to do all that heavy lifting for us. Step number three, set a cutoff sample score or critical value. We're moving away from this now, so we're going to take a look at setting a cutoff probability. Luckily for us, this is one of the easiest things to do. Your cutoff probability is your alpha level that is given to you in your question. And in this case, our alpha level is 0.05. So once again, this is a very simple step. Don't touch alpha. Alpha's alpha. Alpha's left alone. Alpha's not for you to do anything to. And alpha in this case is 0.05. So that's our line in the sand probability-wise. Determine your sample score on the cutoff distribution. We are changing this now to determining your sample's probability on the cutoff distribution. Much like our discussion here, remember that scores and probabilities are locked together, so one can stand in for the other. So we're looking for our p-value, the probability of our sample occurring, and SPSS will do this for us as well. So those are steps 2 to 4 that we need to do, so let's fire that up. So the data that you need is found in week 12, class 1, practice chapter 9. As usual, you have the screen grabs available for you in terms of how to set up SPSS. But for right now, let's do this live so we can see exactly how this is done. All right, so what we're going to do first is I am going to sign into my IU Anywhere account. And if you haven't already, I highly recommend get that Citrix receiver going. Use IU Anywhere, not just for this class. They have a ton of resources available for you. And if you haven't seen it already, this is basically how you sign in. So sign in with your IU username and password. And then it will take you, if you've never used it before, just so you know, it'll take you to your favorites tab up here. And you will have nothing here. And just so that you don't make the mistake, if you search favorites and you don't have any favorites, you will return nothing. So if it's your first time using it, go to apps. So click on the apps tab here. And then searching all apps, you can find SPSS. And we have the 2 latest versions, 25 and 26. And if you click on details, you can add them to your favorites, at which point they'll pop up here. So we'll use SPSS 25. And we will launch that. And we will begin in just a moment. So while that's starting up, let's take a look at our data. So here we have our eyewitness memory, and we have the smashed into, and we have the hit. So let's zoom to that selection. It's not much bigger, but there we go. So again, we need those raw scores. We need the actual raw data, and we have calculated in SPSS, and I highly recommend doing this. Whoops, we have calculated in SPSS the means for the smashed into group. We have calculated the means for the hit group. Very quick little calculation. Make sure that you're doing that. Get into a habit of doing that just so we can double check our setup. Okay, so what are we going to do right now? Well, we got to set up our data. Let me just make sure that I have it so it's consistent. All right, there we go. So we got to set up our data. So what we're going to do is we're going to start off with the smashed into group. So we're going to highlight all of the raw scores for the smashed into group. Make sure that you do not highlight the heading, because that will trick SPSS into thinking that you're giving it a series of words. But we highlight the speed scores for the smashed into group. We go to SPSS, we hit paste, Control V, or however you want to do it. If you have the type of access where you are not allowed to copy and paste into SPSS directly, you will have 3 lines here. Click on those, you will see a clipboard. Click on that, paste it into the clipboard. That will put it into SPSS's clipboard, at which point you can paste it later. So this is another reason why you want to make sure that you're using this, getting familiar with it, so that you can figure out all those little idiosyncrasies. All right, so we have our scores in here. Notice once again, SPSS has named this, very good name for a robot, var 00001, horrible name for a human. So let's go into the variable view. So down at the bottom left, you got data view, that's where your numbers are. You got variable view, that's where your variable information is. And let's just change this to speed, something that will jog our memory, something that's 8 characters or less, so that we are sure that SPSS is never going to throw a fit. And we go back here and we see that speed is now labeled. So those are the 15 estimates for the 15 subjects in the speed condition. What we're going to do now is we are going to type in the group name for this group, for this sample. So in the next column over, we are going to write smashed, and we are going to label each of those scores as belonging to the smashed group. All right, so we have to let SPSS know which group these scores came from. So we are going to write smashed, and if you know how to copy and basically copy and paste in SPSS, that's awesome. If you don't, you can always go to Excel and use your copy and paste skills in Excel to kind of format this stuff as well. There's no need to format things in SPSS. Oftentimes I'll format things completely in Excel and then copy and paste it wholesale into SPSS. Whatever you like to do, that's fine as well. But we need to label each one of these as coming from the smashed sample. All right, so I'll give everybody a moment or two to make that happen. All right, so I hear the typing has died down. So once again, this is our second variable now. It's being called var 00002. Horrible name. Let's go back to variable view. We'll click on that name and we'll change that to group. Something that can jog our memory, let us know that this is a group that we are, group name that we're using. Now notice here that in terms of the type of variables, the first variable, speed, SPSS is labeled that as a numeric variable, meaning that it thinks it's a bunch of numbers. And in fact, it is a bunch of numbers. The second one, group, SPSS is labeled as a string variable, meaning that it thinks that you're trying to give it a bunch of words, and it's correct. We are trying to give it a bunch of words. SPSS will not allow you to do certain things with string variables that it'll allow you to do things with numeric variables. So if you're ever setting up a hypothesis test and your variables are missing from your dialog text box, test boxes, that's probably one of the things to check. Is it mislabeled as a numeric variable? All right, so we have the smashed group all good to go. Is everybody at this stage? Okay. So the next thing we need to do is we need to get our hit group in there. So we highlight our hit scores, our 10 hit scores, and now we have a question of where do we put them in our SPSS input. Do we put it here in column number 3 where we would have 10 hit scores, and then in column number 4 we would label that as being from the hit group? Or do we put it down here, our 10 hit scores, and then label it in column 2 that they come from the hit group? So that's a decision we need to make. Only one of those is correct. And the way to remember this, the easiest way to remember this, is that in SPSS, every single subject gets one line, one row, and one row only. So we have 15 subjects in the smashed into groups, and they take the first 15 rows. You can't put subject number 1 from the hit group in row number 1. That's the group, that's the row for the first subject in the smashed into group. That row is already taken. So that eliminates the option of putting it into column 3. The only place we can put it is into column 1, directly below our smashed into group. So we paste it into row 16, goes all the way down to row 25, and notice that this makes sense. We have 25 subjects in our experiment, and we have 25 rows that are going to be filled with data. So that's an organizing principle for SPSS. The number of subjects you have in your study has to be the number of rows that you enter your data in. Every single subject gets one and only one row for themselves. So we put our hit scores, our hit estimates of speed into that first column, and then we got to finish it off by labeling all of those scores as being part of the hit sample, the hit group. And once we're done, and once it looks like this, we have it all properly formatted. So I'll give everyone just a moment to catch up with the formatting. Get those hit sample labeled. And we will then run this test and see what it tells us. All right, I hear the typing dying down. I think it's good to move on. So once again, now we formatted the data correctly. Now we need to tell SPSS what test to run. So once more, we go back to analyze. We go back to compare means. That's where every single test that we're going to be doing this semester resides. As you can see, SPSS has a million other things it can do. It's a very powerful program. And as you progress, you'll learn more and more about the other types of tests. But for this intro to stats, we go to analyze, we go to compare means. This time around, we're doing an independent t-test. And this is the one where SPSS is kind of friendly, but not 100% friendly, sort of friendly, a bit of a frenemy on this one. So we're looking for the ones that we want to do. And the one that we want is this independent samples t-test, not the summary independent samples t-test. So it's kind of friendly because we're looking for an independent means t-test, and it says, hey, here's an independent samples t-test. But then it gets a little mean and it says, hey, how about this other one? Let me try to distract you. Don't get distracted. It's the independent samples t-test. That's the one that we want. So we click on the independent samples t-test, and we get our independent samples t-test dialog box here where we can set up our independent samples test. All right, so we got two windows here that we need to populate. One is the test variables. Where are our raw scores? The other one is the grouping variable. Where is the names of our groups? So the test variable here is speed. So we click on speed and we use the arrow to pop it in. If we make a mistake, we can pop it back out, pop it back in, pop it back out. But let's say that we clicked on group instead and we try to put it into the test variables. You'll notice that SPSS will say no. It'll say group is a bunch of words, and I can't put a bunch of words into the test variable. So again, if this happens and you get this message and that variable is where your raw scores are, that just means that SPSS thinks that your raw scores are words, and you need to go back and just basically delete them and repaste them in. So let's do this correctly. We'll click on the speed, we'll pop it into the test variables there. The next thing we need to do is we need to tell SPSS where our group names are, and that's your grouping variable. So you click on group, you use this arrow here to pop it into the grouping variable, and you'll notice that SPSS will say, all right, you got two groups, what are their names? Right? What are the names of your two groups? So we're going to go here and we're going to define groups. And here is where you tell SPSS the names of your groups, and you have to be exact. So we have one group that's called Smashed, and we have to tell SPSS our group is named Smashed. Not Smash, not Smushed, smashed. We got group number 2, it's called hit. So we have to be very exact when we put in our names. Because let's say that we make a mistake. Let's say that we put 2 I's in hit. Let's say that we had an itchy typing finger. And instead of hit, we put in HIIT, high impact interval training, or whatever. If we hit continue, if we hit OK, SPSS is going to give us an output here that basically says, I can't do your test. So if you enter in everything and SPSS comes out and says something like this, gives you a table that is basically empty, that means something went wrong in your setup of the test. And if you look at the group statistics here, you'll see that SPSS is saying, oh, there are 15 scores in the smashed into group. There are 0 scores in the hit it group. And that's when you have to realize as a human, oh, I made that mistake. Let me go back. Don't need to save that output. Go back to analyze. Go back to compare means. Go back to independent samples t-test. It's still all set up. Click on your groups. Define your groups. Make your correction. And whoops, make your correction correctly. And then you're ready to go. So once we have the names entered in correctly, we are good to go. We hit OK. And we have our actual calculated SPSS independent samples t-test. All right. So let me bring up those numbers.
What if it still says warning?
That means that you still did something incorrect. So I will come by and let's take a look at what that is. All right, is anybody else running into the problem where you can't get the output? Does everybody have something that looks like that at this point? We're all good? All right. So for some of you, you have encountered that 90s flashback warning that I mentioned for SPSS. So once again, if you keep your variable names, variable labels to 8 characters or less, it's guaranteed to work every single time. For some reason, for some of you, SPSS assigned you a variable length of 12. That apparently is, too long. In 2019, it's still too long. So that's one of the things where I was mentioning, just be careful with the length of your variables. SPSS will make it as long as you need it to be when it first sets things up. And then the easiest way to get around that is that if it doesn't work, just delete your entire column and then copy and paste the data into a new column, relabel it, and just start all over again. Because you need to know a lot of the intricacies and inner workings of SPSS to kind of backtrack and fix it. It's better just to clear the whole thing, go in there and fix it up by just redoing it wholesale. All right, so now that everybody's on track, let's take a look at how to interpret this output here. So once again, we are going to want to do every single stage of this hypothesis test. So we need step 2, where we have our comparison distribution. So we need the mean, we need the degrees of freedom, and we need the estimated standard error. Step 3, we need our cutoff probability. That's our alpha level. We can pop that in right away. And then step 4, we're going to want I'm going to show you where to get your t statistic, because your homework will want your t statistic. But more importantly, we're going to look for that p-value. What is that p-value that we're looking for, and where can we find that information? All right, so again, we are going to decide whether to reject or accept the null hypothesis. But rather than using t-scores and cutoff scores, sample t-scores and cutoff t-scores to make that decision, we are transitioning to using sample probabilities and cutoff probabilities to make that decision. And once again, this is just so we don't have to go to the t-table to look up those cutoff scores. All right, so again, until the logic makes sense, refer to those 2 slides to help you make those decisions. But let's dive in and take a look at this output. So, first thing you want to do, always the first thing you want to do, is you want to check this top table over here and just make sure that your data has been entered correctly. So the independent means t-test, because you're copying and pasting things and then labeling the groups, is notorious for mislabeling or mispasting. So I have seen people when they're writing in smashed, they go one too far, or when they're writing in hit, they go one too many, they start, where they're not supposed to start. It's really easy to make that mistake. So what you want to do is you want to go up to this top table here and just check to see how many scores you've given SPSS. And SPSS will say, I got 15 scores in the smashed into group. I got 10 scores in the hit group. Double check with your Excel sheet and be like, oh, okay, yes, you're supposed to have 15 in smashed, you're supposed to have 15 in hit. Gives me confidence that we copied and pasted correctly. You also want to check out the mean calculations. So you've done these in Excel, where you calculate the mean of your raw scores, compare them to what SPSS is saying the mean of the raw scores you gave it are, then make sure that they match up. And again, this is just a way to give you confidence that you have copied and pasted correctly, because as we've seen, things can go a little wonky sometimes in SPSS. All right, so step 2, determine the characteristics of your comparison distribution. SPSS will do this. So the first thing that we need, or the first thing that we're going to look up is, I believe, I'm going to make a mention about where to go first. All right, so the first thing to know is that we got 2 rows here. The row we're going to stick to is this equal variance is assumed. Now, equal variance is assumed is a holdover from the days before these computers, before these statistical programs, where these poor grad students were locked in their ivory towers and they were doing statistics with huge stacks of paper and nothing but a calculator, and even before then, maybe just an abacus. So the reason that they have these 2 columns is that if you assume equal variances, the amount of paper that you need to do this calculation goes from this much to this much, right? Still a lot of paper, but way easier if you assume the variances for your 2 populations are equal. These days, you don't have to make that assumption. However, this is your intro to statistics, and equal variance is assumed typically is correct. Equal variance is assumed is typically the one that's reported. For this intro to stats, equal variance is assumed is the one that we are going to be using. So stick to this top row right there. That's the row that we're going to be looking at for this intro to statistics. When you go to grad school and you take your next series of statistics courses, you'll learn all about that second row. For this intro, we're going to stay in that top row. All right, so step 2. We need degrees of freedom. Very nicely labeled right there. So there's your degrees of freedom. We got 23 degrees of freedom. That is the size of one sample minus 1, plus the size of the other sample minus 1, or you can just look for it on SPSS. This is your help if you need to look up your cutoff scores. This is how much SPSS is going to help you. It's going to tell you how many degrees of freedom you need, or you have, in order for you to look up your cutoff scores. We're not going to do that. We're using this comparison distribution. So we got our degrees of freedom. Next thing we need is we need our estimated standard error. Notice that we have 4 standard errors. We got 2 standard errors of the mean up here. We got 2 standard errors of the difference down here. So only one of those is the right one, and it's that one right there. So make a note in your lecture notes. That's the standard error that we're looking for. So the estimated standard error is 2.588. I'll just round for that. So that's the standard deviation of our comparison distribution. Nowhere on SPSS is it going to tell you the mean for your comparison distribution, and that is because for an independent means t-test, much like a dependent means t-test, the mean for your comparison distribution is always 0. So SPSS doesn't have to output that because it'll never change, it's always 0. So just to make it complete, I'll write that in there, but it's always going to be 0. Okay. So that was step 2, that's where you find that information. Step 3 Step 3, set your cutoff probability. We've already done that, but just to make it, just to drive home that point, at your alpha level. Your alpha level is your cutoff probability. If you're looking for your cutoff score, you would take your alpha level and your degrees of freedom. You would go to that t-test table, and you would find that line in the sand. Or, we'll use the probability as our line in the sand. We can do it all from SPSS. All right, step 4, determine your sample's probability on the comparison distribution. That's your p-value. SPSS will calculate this for us. So, before we get to the p-value, just so you know for your homework where you can find your t-statistic for your sample, in this case, your t with 23 degrees of freedom statistic, that takes into account the mean difference. So this is the mean difference between the two samples. Take that, divide it by your estimated standard error, and you will get your t-statistic, which in this case is 2.628. All right, so in your homework, when you need to report that t-statistic, SPSS calculates it out for you. That's where it is in this one here. So now the last thing that we need is our actual p-value. So for this one, this is again SPSS not being very friendly. Notice that we have significance over here. That's SPSS's word for probability. So we got significance right there. We got significance two-tailed right here. And we got two numbers right here. So we got one number, two number, three numbers. We got to know only one of those is the correct number, and it's that one right there. So don't get distracted with this significance. We're not ever going to use this. Don't get distracted with that. Look for the significance two-tailed. That's our p-value. And because we're doing a two-tailed test, we can read it straight off of there, and it's 0.015. If we were doing a one-tailed test, we would take that probability and we would divide it by 2 in order to do step 4 and step 5. But we're doing two-tailed, so we're actually going to use two-tails. So SPSS has done that for us, so we have our two-tailed probability. All right, and now we make our decision. So, if our probability, if the p-value, the probability of our sample is less than our alpha, 0.015, is less than 0.05. So we are going to accept the research hypothesis and reject the null hypothesis. If, on the other hand, the opposite was true, then we would do the opposite. We would accept the null hypothesis and we would reject the research hypothesis. As it is, our p-value is 0.015. That is less than 0.05. Please be very careful when you're comparing decimal values. I have seen students immediately kind of look at, oh, that's 15, that's 5. 15 is bigger than 5. It's not 15 versus 5, it's 15 versus 50. But just make sure that you're taking your time, compare these two when you're comparing those, because you don't want to make a mistake here and go the wrong way. So the p-value is 0.05. That is less than our alpha. We reject the null hypothesis, and we conclude that there is an effect of how you ask the questions. People in the smashed into group actually did report higher speeds than the hit group. All right, so that is the independent, that is the t-test for independent means. Any questions on what we've gone through or where to find that info? All right, awesome. So just another reminder, another plug. Make sure that you're picking up your 100% points from the MyStatLab study plan for your pretest points. Especially now, it's getting very challenging to get 100% on those pretests. Especially now, we're doing it sometimes before SPSS. So on that note, feel free to use SPSS for whatever it is that you're doing. If you're trying it with your pretest, use that as part of your learning process as well. Go on YouTube, check out how to do some of these things, online. Check out some of the resources. Look at the tutorials in SPSS. And that'll really help reinforce what we do here as well, just seeing it one time before. But if you're not feeling that frosty, then do your pretest, still work through them. But just know that if you're not able to get a good score on your pretest, after you learn about it, do the MyStatLab study plan, get those mastery points, and bump your pretest back up to 100. In terms of practice as well, there is extra practice available now, so we'll devote the rest of the in-class time to this. So you got extra practice available in the Excel sheets where you find your raw scores, and then there's a supplemental practice PowerPoint file, which will give you the question, it'll give you the SPS output you're supposed to get, and then it'll also give you the answers to the 5 steps here. So that's your kind of answer key to kind of work through. So give it a try on your own without looking at the answers, and then you can double check to see how well you did. And we got homework assignment number 12, chapter 9. That's going to be due November 18th at midnight. So not before next class. We actually got a little bit of time because we're going to do one more class on independent means t-tests. Basically, it'll wrap up t-tests as a whole and figure out how to decide when to do each of those t-tests. So you actually have the skills that you need to do this right now. You're good to go. But you do got a little bit of time to do that. So, bear that in mind. Go out and build a snowman. So anyways, that's all that I wanted to cover for today. So if you're all statsed out, feel free to call it an early day. But we got about 20 minutes, just under 20 minutes remaining. So I would highly recommend give those independent means t-tests a shot. Make sure that it's all working for you. And call me over if you're having any difficulties. Other than that, I've covered what I want to cover today.